Alright, okay, the trig, make sure your calculator's in degrees, or I guess if you want it to be in radians, make sure you know what it's in. Okay, this problem. First of all, everything is in radians, so unless you're familiar with radians, let's probably convert it to degrees. So if you've got pi over 6, that angle is pi over 6. So degrees times it by 180 over pi, and that is equivalent to 30 degrees. So if this is 30 degrees, then it's a 30, and this is a 60, and that's a 90. So that means it's equilateral. So that means this is 1, this is 1, this is 2, this is 2, and this altitude of it, or this base, is going to be 1 times the square root of 3. So now you drag and drop that there, but 60 degrees, everything's going to be in radians. So if you change 60 degrees into radians, you're going to times it by pi over 180. And 60 and 180, if we simplify these, divide them both by 60, that's going to change to 1. That's going to change to 3. So pi over 3 is the same thing as 60 degrees. So all these pi over 3's, they're talking about the 60 degrees. So theta, they want you looking pi over 6. They want you looking right here. Sine is going to be opposite over hypotenuse, so that's 1 over 2. Pi over 3, theta, they want you looking right here. Sine is going to be opposite over hypotenuse, so it's going to be square root of 3 over 2. Cosine of pi over 6, cosine of 60 is adjacent over hypotenuse, that's 1/2. Cosine of pi over 3, pi over 3, that's 60. Wait, I think I messed up. Cosine of pi over 3 is 60. This is the one that's 1/2. This one right here, cosine of pi over 6, is actually my 30 degrees. So cosine is adjacent over hypotenuse, so that should be square root of 3 over 2. And then your tangent of pi over 6, tangent is opposite over adjacent. It's 1 over square root of 3 times, you can't have a radical on the bottom, so you times both the top and bottom by square root of 3, and you should end up with square root of 3 over 3. But the tangent from 60 is opposite over adjacent, so it's square root of 3 over 1. Okay, number 2. They want the volume. So the volume of a cylinder is just the area. So capital A for kind of area of the circle. Multiply that by the height of the cylinder. So if I find the area of a circle, and the area equals pi times radius squared. So it is going to be, the radius is going to be 4. And 4 squared is 16, so the area is 16 pi. And times that by the height, and the height, we don't know what the height is, but we can use Pythagorean theorem. So we can use 8 squared plus x squared, and that's got to be the hypotenuse squared, which is 16 squared. So if I do x squared equals 16 squared plus 8 squared, if I ditch the square root, so the square root of 16 squared plus 8 squared, and if I just type that in on my calculator, I think it's going to give me a decimal, and none of these answers are decimals. So I need to figure out what 16 squared plus 8 squared is. 16. So that's the same thing as the square root of 320. Now let's see if that's perfect square. Type in square root of 320 and hit enter, and it does give you decimal. So you need to pull the squares out of 320, find out how many squares are in 320. So if you break 320 down to its prime factors, so if I do 32 times 10, 32 is 8 and 4, 8 is a 2 and a 2 and a 2, and a 4 is a 2 and a 2, and a 10 is a 2 and a 5. So in 320, there's 2 to the 6 times 5, and remember every pair of 2's comes out, so that means 3 2's are going to come out. So on the outside you're going to have 2 cubed or you're going to have 8. On the inside, you're going to have 5. So on the outside, we got 8 square roots of 5. Okay, that's the height. So my height is going to be 8 square roots of 5. And if I times that by the area, which was 16 pi, then all you do is multiply your 8 and your 16. And that's going to give you 128 times pi times, see, I got a 5 in here, times the square root of 5, but none of these are 5s, and it was 3 because it was 2 to the 6th, and what was left over, oh no, I did get a 5 left over. I should have got a 3 left over. How did I mess up? So anyway, we're going to go with 128 pi times square root of 3. And someone help me figure out where I messed up. It must have been when I busted up 320. I must have done it wrong. I did 32 times 10. And 32 is 8 and 4. So maybe it's not 320. Anyway, someone help me out. Okay, this next one. Which statement is true? So you got A, B, C, D. You can plug them all into your calculator and see which ones are equal. But these are radians, so you got to turn them to degrees, or you got to change your calculator to radians. But what they're fishing for is the trig is going to be the same on coterminal angles. And coterminal angles, so if I've got an angle that's 30 degrees, so it ends up in quadrant 1, 30 degrees. The trig on 30 degrees is going to be the same thing as if you add a full rotation. If you add 360 to it, that's going to be 390. So I do a full rotation and then go another 30. That's the exact same angle, plus a rotation or minus a rotation. So coterminal angles are going to give you the exact same trig answers for all of the trig functions. So this first one, if you look at, so they're all 7 pi over 3. So 7 pi over 3, if I times that by 180 over pi, the pi's cancel. 3 goes into 80, 180, 60 times. So 60 times 7. This 7, all these 7 pi's over 3 are 420 degrees. So 420 degrees. So if I do 420 minus 360, what we are looking for is 60 degrees left over. So the trig on 420 is going to be the exact same as the trig on 60. And 60, we just did one of these guys right here was 60 pi over 3 or pi over 6. So if we do pi over 3, and you times that by 180 over pi, pi's cancel, 3 goes into 180 60 times. So it's going to be A. The trig on 60 degrees, which is pi over 3, and the trig on 7 pi over 3 or 420 degrees is going to be the same because they're coterminal angles. Okay, a circle has a diameter of 18 inches. So that's the dead center. And it's divided into 6 equal sectors. And they want the perimeter of each sector. So it looks kind of like an ice cream cone. So if the diameter is 18, each of these are going to be 9. And then if I know this angle right here, which is going to be the total divided by 6, because I divided it into 6 equal portions. So 360 divided by 6 is each portion is going to be 60 degrees. So this right here is 60 degrees. Okay, now the perimeter is going to be the way all around the edge of this shape. So I've got 9 plus 9 is 18. So far B and C are looking good. So 9 plus 9 is going to be 18. Plus I need this arc length right here. And the arc length is going to be kind of a, you can use a proportion or you can change it to radians, because radians measures arc length. So I'm going to change this to radians. So 60 degrees, I'm going to times it by pi over 180 degrees, and that is going to simplify 60 and 180. That's going to be pi over 3. Okay, now that's radians, and radians measures arc length of the unit circle. So if your circle, if all of these guys were 1, 1, 1, and that was the 60 degrees, the radians measures the perimeter of this arc length right here. So this perimeter, this circle was times by 9, so I'm going to times this arc length by 9. So I'm going to take the radian, which is the arc length when the circle's 1, but now because the circle's 9, I'm going to do pi over 3 times that by 9, and that's going to be 3 pi. So this distance right here is 3 pi from here to here, so the radius or the perimeter is going to be 3 pi plus 18, and we're going to go with B. Okay, so given the unit circle, that means each of these are 1. The angle shown is 2 pi over 3 radians. Estimate the length of the arc shown in red. So that's what we just barely did. So if this angle, 2 pi over 3, that's actually the same as the arc length of a unit circle. So we're going to go with 2 pi over 3. But 2 pi over 3 is not A, B, C, or D. So you need to approximate, change this to a decimal. So do 2 times pi, and then divide that by 3, and it will give you the decimal, and it's some as close as 2.09. Okay, this one you kind of got to draw a picture. So Xavier cannot walk from A to B because there's a pond in the way. Instead, he starts walking at a 30-degree angle from the direct path. So let's call this B and let's call this A. So from A to B, he can't go because there's some kind of a pond in the way. So he veers off. He tries to get outside the edge of the pond. So he takes off at a 30-degree angle from the direct path. Then he makes a 90-degree turn. So I think I got my picture wrong, because the 90-degree angle, I've got it being right here, but it needs to be right here, because that's not a 90-degree. And then walks 40 feet to his destination. Alright. So the triangle I need's got to be like this. So he goes from A, but here's the pond in the way, so he can't go straight from A to B. So instead he turns 30 degrees, starts walking, and then he turns 90, so he makes straight left, and he walks 40 feet. So this distance, if we call this guy C right here, from C to B is 40. Okay, so if he could take a direct path, how far would his path be? So I need this distance right here. I need to find the hypotenuse of this triangle. So I'm going to use theta for my 30, and because it's 30, hopefully we got that memorized. Don't even need to do the trig. If that's 30, it's half of an equilateral. Here's the other half. I always flip it over the 30. So that means that's 40. That means these are both 80. So the distance would be 80. Or you could use trig, you'd have to use the sine. Sine of 30 is the opposite over the hypotenuse, and then solve for the hypotenuse. Okay, in the figure shown, phi, which is this guy right here, the sine of phi is 3/5, so that's opposite, that's hypotenuse. But this shape right here is not a triangle, some kind of a quadrilateral, but if I made it a triangle, it wouldn't be too bad. So if I start from this point and I go straight across right here, and I know this is a rectangle because all the corners are 90 degrees, so the rectangle that has kind of a cool feature, this top is congruent to this bottom, and this side is congruent to this side. So you don't know it's a square though. You don't know that all sides are congruent to each other. If it's a rectangle, you just know opposite sides are congruent. So the sine of phi, if I put phi right here, is going to be opposite. That means this side is opposite over the hypotenuse, and the hypotenuse is opposite from the 90, so this is 5. And then if that's 3, that means this is 3, and that means this is 3. And so now they want the cosine of theta. So theta is here, cosine is adjacent over hypotenuse, so it is 3/5 also. So a good question would be if they would have asked you for the sine of theta. So the sine would be the opposite. That would be this piece right here, and you could use Pythagorean theorem to find that. Okay, this is a good question. They want to know approximately how big is 1 radian, and here's what you know. You know that pi radians is equal to 180 degrees. So that's what we know. Half of the unit circle is pi radians. But we need to change this to a number. So pi is approximately 3.14 radians. So in a half of a circle, there are, in a half of a unit circle, there are 3.14 radians. So the question is, how much is a single radian? So if I do 180, if 180 has 3 radians, I'm going to divide it by 3.14 radians, and that should give me approximately how much 1 single radian is. So 180 divided by 3.14, and 1 single radian is approximately 57.3 degrees to the nearest tenth. So if you need to make an angle that's 1 radian, it's going to be something like this, 57.3 degrees.